Welcome to Wildcat Science with Mrs. Helgo. This is Chemistry, Chapter 2, Part 11, and we are in the third section. And as promised, we are going to talk about molarity. So molarity is a good way of describing concentrations of solutions, which are mixtures. So please write that down. It measures concentration. And if you notice, the the variable or the letter we use for molarity is a capital M, also the unit, so it's both. Why? Why are we learning another way? So knowing molarity of a solution helps us, of a solution in a lab is very useful because chemicals react in mole ratios during reactions. So for example, 1 mole of copper reacts with 2 moles of chlorine to make copper 2 chloride. It's not like 1 gram of copper reacts with 2 grams of chlorine to make copper chloride. So we need to know the moles. Another example where we would need to know molarity. We need to make a 1 molar solution of hydrochloric acid for a freshman lab. So being able to know molarity is very helpful in the lab. So let's calculate that. What do? Well, first off, we're going to make sure our volume is converted to liters. We're going to make sure our mass is, if you are given a number in mass, we're going to make sure that we convert it into moles. And then we're going to write down this equation. Molarity equals number of moles over liters of solution. Then we're going to plug in our known quantities and solve for the unknown and make sure our units are correct. So let's do an example where we solve for the molarity of a solution. So please write down this example. If 10.0 grams of citric acid, which is C6H8O7, is added to water to make exactly 500 milliliters of solution, what is the molarity of the solution? So first thing we're going to do is we're going to write down what we know. Okay, so we know we have 10 grams of citric acid. We know we need 500 milliliters of solution. And we're trying to figure out the molarity. So we have 10.0 grams, and then citric acid is C6H8O7. And then we know we have 500.0 milliliters of solution. And our question mark is the molarity. Great. Our next step is always to calculate. So we're going to convert volume into liters. So we have 500 milliliters over 1 times my conversion factor. Well, milliliters is going to have to go on the bottom, and I want to go to liters. So in 1 liter, there are 1,000 milliliters. Milliliters cancel. Take 500 times 1 divided by 1 times 1,000, and that would be 0.5 liters. And I do want to remember that that has 1, 2, 3, 4 sig figs, so I should probably add those in so that I don't mess up with my significant digits. 1, 2, 3, 4 liters. Great. Then I'm going to convert the mass of the solute into moles. Okay, so I have 10.0 grams of C6H8O7. So remember, when I am converting mass to moles, I need to know my molar mass of the compound. So that's the first thing I need to do. And remember, when we are doing the molar mass of the compound, we're going to take our mole ratios of each of our elements and times it by that. Okay, so I wrote it over here so that I don't have to keep scrolling up and down. So in each mole of citric acid, I'm going to have 6 moles of carbon over 1. This is where I'm going to get out my handy dandy periodic table, and I know the molar mass of the atom of carbon is 12.01 grams in every mole. And then I know I have in every mole of citric acid 8 moles of hydrogen over 1 times the molar mass of the atom hydrogen is 1.01 grams in every 1 mole of hydrogen. And then I know that I have 7 moles of oxygen. And I know that the molar mass of the atom of oxygen, rounded to the nearest 100, is 16.00 grams over 1 mole. So please take a moment and figure out the molar mass of citric acid. Okay, if you got the molar mass is 192.14 grams, you are correct. Good job. So I got an answer, I'm done, right? So I go back and I look at the problem. What is the molarity of the solution? Oh, 192.14 grams is not a molarity. So then I solve number 2, convert the mass of solute into moles, right? 192.14 grams is not moles. Okay, so I didn't even do that part yet. That is the molar mass, which I'm going to use to convert mass to moles. So I know that my mass is 10 grams. So I'm going to start with that. 10.0 grams C6H8O7 over 1 times, if you remember converting mass to moles, I take my mass and then I times it by my molar mass. So I want to go to moles. So 1 mole has to be on the top, and then on the bottom is going to be the molar mass in grams, which I just calculated, which is 192.14 grams. And then that will get me my answer. I cancel out my units, grams, grams. I'm left with moles. That's what I wanted. So I'm going to take 10 divided by 192.14. So please get out your calculator and figure out the number of moles of citric acid. Okay, if you got 0.0520 moles of citric acid, good job. I noticed that I have 3 sig figs and 10.0. So I'm going to keep 3 significant figures. The first 2 are placeholders, and then the 5 and the 2, and then that 0 after the decimal point is significant, so I have 1, 2, 3. All right, now I have moles and liters, so now I can write the equation and plug in my unknowns. So please do write molarity equals number of moles over liters of solution. And then coming back, we are calculating our molarity, and we know our volume, and we know our moles. So molarity, its variable is m, and the number of moles we just calculated. Let's scroll back up and make sure we get it right. 0.0520 moles over our liters of solution is 0.5 and 3 zeros after that. Keep track of our significant figures. 1, 2, 3 liters. Okay, so then I bring down my variable and my equal sign, lining them up. So please get out your calculator and do that math. Okay, did you get 0.104? If you did, good job. So let's look at our answer, if it's reasonable, if we did the right number of sig figs. So the question way up here, if 10 grams of citric acid is added to water to make 500 milliliters of solution, what is the molarity of the solution? Well, that has 3 sig figs, that has 3 sig figs, and my answer is placeholder and then 3 significant digits. Great. Sig figs are right. Did I answer the question? What is the molarity? And I did get a molarity. The capital M stands for molar. So 0.104 molar solution. That's the unit for molarity. Now the big question, is it reasonable? All right, so if 10 grams is added to half a liter, what is the molarity of the solution? Okay, so looking at our molar mass, if I had a 1 molar solution, I would have 1 mole in 1 liter. So if I had a 1 molar solution, I would have 1 mole, which would have a mass of 192.14 grams. Let's round that up to 200, make it easy. But I don't have a whole liter, I have half a liter. So if I had a 1 molar solution, half of 200 grams is 100 grams. So if I had 100 grams, if I had a 1 molar solution, I would have 100 grams. Well, I don't have a 1 molar solution, and I don't have 100 grams. I had 10 grams. 10 grams is 1/10 of 100. So my answer should be about 1/10 molar. And it is. So, good job, we got a reasonable answer. So now let's do nothing new. We're just going to solve for a different variable. We're going to do another practice problem. So you don't need to write this part down, but it's a good lead into the problem. Ascorbic acid acts as a food preservative by reacting with oxygen that would otherwise ripen or spoil the food. Now please write this down. How much of a 1.0 molar ascorbic acid solution is needed if 0.040 moles of ascorbic acid is needed to completely react with the 0.020 moles of oxygen in the bread bag so our bread doesn't spoil and then you get home and you bought rotten bread and you're mad at the grocery store. First thing we're going to do is we're going to write down what we know. Okay, so we've got a lot of numbers in here. So how much? So is that molarity, volume, or moles? How much of a solution? Well, that's going to be volume. And we know our molarity is 1.0 molar. So 1.0 molar is my molarity. If 0.04 moles and 0.20 moles, wait, there's 2 different moles. I can't do a problem with 2 moles. There's only one place for moles. Give up and go home? No. Only one of these is applicable. So if we're looking at a 1.0 molar ascorbic acid solution, should we use the number of moles of ascorbic acid or the number of moles of oxygen? The number of moles of ascorbic acid. So that is our number of moles, 0.040 moles. And then, like we already figured out, our question mark is our volume. So calculate. Convert volume to liters. Well, that's what we're solving for. So when we do the problem, it will already be in liters. Convert mass of the solute into moles. Well, it wasn't given in a mass, it was already given in moles, so that part's already done for us. Then we write the equation, plug in the known quantities, and solve for the unknown, and make sure to check your units. So please do write down molarity equals the number of moles over the liters of solution. And then we're going to plug in our numbers. All right, so molarity is 1.0 molar equals our number of moles was 0.040 moles. Double check we got that number. And then over our unknown, which is V. Now, when we're solving for V, we can't just multiply these together because that'll give us the answer for 1 over V. Actually, it'll give us 0.04 squared over 1 over V, so that would be really not the answer we need. First thing we're going to do is we're going to take V on each side. That cancels our V, and then we get V times 1.0 molar is equal to 0.040 moles. Our next step is to get V by itself by dividing each side by 1.0 molar. And these cancel and we get V equals, and I would like you to get out your or if you can do it in your head, great. And then we're going to do a little bit of a cliffhanger and go over the answer in the next video. I will see you then. Bye.